Hello friends, let's continue our journey to learn. Earlier we learned a use case on how to use it for text to SQL conversion and accessing database to get the information by just writing a natural language and the agent converts it into a SQL query. So let's understand another use case. Like we all use Perplexity and ChatGPT and other tools. So as I was using this tool, I was thinking for our need basis chatbots, like for a airline industry or a particular some gas and energy company to book the new connection or find the billing about details on for existing customer and so on. We create chatbots, but when the domain is such a vast where you ask questions, and when I really get impressed when Perplexity gives such a detailed response and information how it would be doing. Can we create that many agents dynamically? So it's not possible to create that many agents dynamically. So I was just thinking, and I created an agent which will create a lang graph object which will have multiple nodes and edges, and which will do the desired action and get the output. So I will divide this learning in two parts. In first part, let's understand the design and understand, and then in the next video I will share how the agent works, we include different design patterns for a agentic solution, and that agent creates a lang graph object for different kind of questions, for a student, for a tourist looking for a place and to go visit, and so on. So for such a solution, what we need? Generally, whenever we talk to a system or to another person, we go to the front desk or a kiosk, that person tries to understand what is our intent from a dialogue which we have, and from that intent it decides the goal, and for every goal certain actions attributes are required. Suppose I say I want to send an email. So to send an email, we need to have whom do you want to send the email, what is the subject, and what is the text and the message to be sent. So that becomes the goal attribute. Similarly, if I say I want to arrange a meeting, so to arrange a meeting, I need to the person's invitees, the location, the agenda, and so on. So for that is how from the goal, for every goal to achieve, we need certain attributes to be fulfilled. Okay, so other thing which is input validation and guardrails is guardrails will do the validation. That is for any solution, it is a must. Now how a goal decomposition will be done. So you will have an orchestrator agent. That agent will have all the inputs of the different design patterns which using which a lang graph object can be created and the edges can be defined. So accordingly it will create a dynamically create a lang graph object which will do the actions and get the output and finally give the results. So once this agent, this lang graph object works, you can have it in a loop with using a reason and act execution loop. So there you can have an agent which will monitor the execution of it and the output received and evaluate it with the help of multi-agent collaboration, and then if the output is suitable for the user based on the question and the information we have about the user, it will give the share the output to the guardrail, which will evaluate it, and then send it to the user, right? So in the two loop agent, with iteration, refinement can be done, and guardrails can be used for input, output, and then additional safeguards can be applied. Similarly, if so such questions can be put into the question bank, and this dynamic creation of agent can be in the form of some prompt. It can be saved so that in future it can be used for reinforcement learning and improvising on it with human intervention. So similar questions, if comes up by another user in the future, the answer is more optimized and user friendly. So whenever we interact with ChatGPT or any such solutions like Perplexity, one can ask questions on any domain. It could be education, media, governance, R&D, HR, finance, healthcare, and so on, right? And the system is still able to respond. So there are two kinds of solutions. Like when we create a domain-specific solutions, we define domains based on nouns, and then based on verb valency, we take the actions, right? In the pre-generative era, when we created solutions which would involve NLP and NLU, right? And then if you there was a researcher by the name of Shank, which would say the action should be based on verb valency. In the day-to-day language, person does not speak grammatically correct language. So very same concept is used in the generative AI, where it creates a semantic graph of the question given, and based on the nouns and verbs, it finds the goals and edges for an object which would take the necessary action. So like in a question, it will look for divide it and look for multiple subtasks, and for each subtask it would create different agents, and it would define ages after, so that some agents would be called in a linear fashion, and then some agents would be called in a parallel fashion, and their information would be gathered, synthesized, and given to the guardrail. So in a hard-coded agentic solution, it is a limited, and it has to, for a specific solution implementation, it has to be, it can be done, but while for a dynamic orchestration helps you address vast number of domains, and so accordingly it supports a larger audience. So what are the different components if we want to build such a solution? Like any agentic solution, we need guardrails to guard the input and output shared. We need user interface using which user can give the input and see the output. Then there should be safety policies as per AI ethics, and minimum, so that there is also no hallucination. Okay, so the brain part where the agent works, mostly it will be multi-agent. It needs a understanding of the language. It should be able to decompose the goals into multiple subtasks, sub-goals, and do the action and collect information for each and every sub-goal, and then finally combine that to answer the goal, as per the goal. Yeah. And it should be able to recognize the intent. So from the intent recognition, it finds the goal, and from the goal, it finds the sub-goal. So natural language understanding helps in finding the goal from the intent. Yeah, so then the engine is the agentic part which does the action. So there would be orchestrator which will take the input. It will, based on the input, it will create subtask, and based on the subtask, it will create nodes and edges, and then that a line graph object can be executed where it can it can use the retrieval augmented generation if the knowledge base is available, and otherwise it can use external SERP API calls, which will use Google search engine or any other search engine to get the results, and from those results the scoring can be done to get the output, and that output can be given to an agent, which is a kind of React agent, reason and act, and it will evaluate if it's not desirable, then it will request to further modify the line graph and execute it again to get the desired output. So like any agentic solution, the first part is getting the input, then filtering the input through the guardrails, then check whether it is having any personal information if it which needs to be safeguarded, and then do the scope validation, and if required have a human in the loop. So like in a natural language processing pre-generative era, if a sentence is input is given, for every word the token is whether this word is a noun or a verb, and a NLP tree is created, and based on the domain, based on the noun the domain is found, and based on the verb the action is decided. While in the agentic case, if the same sentence input is given, it will be able to find what is the sentiment of the sentence, what is the intent, and what is the implied goal. Like in this case, the question is compare Q3 earnings for tech corps. The sentiment is neutral, the intent is to do the comparison, and the goal is to do the financial assessment. So agent provides dynamic context and intent understanding. So like take a example and understand this design and how it will work. So like if a user asks, order a chocolate cake tonight, include ingredients, vendors and delivery. So how many subtasks this intent or goal will have? So the goal one is identify from this intent, the first goal is identify the ingredients. Second goal is find the vendors. And if we are able to find the ingredients and the vendor as required by the person giving order, then third option is the delivery option available, right? So orchestrator will be able to parse this input into 3 sub goals, and accordingly will create agents and edges for it. Though I am considering this using a line graph, seems similar thing if we want to implement using AWS step functions. The agent, when we define it to create a line graph nodes and edges, instead of that we can create a JSON object of a step function, right? So how will the dynamic graph construction will happen for it? Like so, first is the ingredient agent, which will find the ingredient, and then the next agent will be finding the vendor. So if we whatever ingredient is required, and once the vendor is found, whether from that what is the logistic option available for the delivery. So this is a kind of linear solution. So let's take some another example where the user asks the quant investing related question. Tell me about the potential benefits and risk of using a new investment strategy called quant investing, and if it's suitable for a beginner. So if we parse this sentence, we will find that it's related to the domain finance. What is the sentiment? So here the sentiment is for a beginner, and then what will be the goals from this intent? that define the quant investing. What is quant investing? Second part is do the analysis benefits versus risk. Then suitable assessment, beginner profile. So like when you get the response where you will get details which would be suitable, could be suitable for a beginner, intermediate, or the advanced investor. So accordingly, it should be able to filter and segregate the output and share only what is suitable for a beginner. The other thing which is like it should be able to visualize what more questions user may ask and accordingly give the suggestions for the user to ask the follow-up questions. So in such a requirement, the very first node required is a information gathering. So for information gathering, it can use a SERP API which will do the Google search, collect all the information. Then it will pass that input to the information extraction. So that will do the summary of all the different information received. So what it can do is all the information gathered from SERP API, there could be another agent which would score all the output, and the top 5 to 10 outputs can be taken for the summarization. Right. The other thing which can be done is if the summarization is score is low, the agent can based on this summary can again do further search and collect more information and then summarize it again. So once the information is summarized and it is and the score is high, it can go to the another agent to do the risk assessment whether it is really suitable for beginner. If there is any content which is not suitable for beginner, need to be trimmed. And that assessment is done, the final answer is generated by the answer formulator agent, and then the output is reviewed by the guardrail and then shared to the end user, and also parallelly stored in the history for future improvisations and corrections. So let's understand how the different agents and ages would look like. As I mentioned, so information gathering is done, then its scoring is done. Once the scoring is done, it calls the next agent for the extraction, and that output goes to the risk assessment based on the sensitivity flag. The fact check is done, and based on the output, the next agent generation is called, and finally the guardrails. So arrows marks the edges and the blocks marks the agents, and these are diamond shaped decision making conditions which can be defined in the line graph object, which will define the flow of the outcome. So what does reason and act agent does? Okay, so whenever any input it gets it will think about it, and then it will plan the next step, and based on the steps required, it will take the actions. How many if there are multiple sub-tasks, sub-goals, it will take do the multiple actions and collect the information. So for doing the action in any agent, there is a tool API calls available, and if information can be gathered, knowledge base is available, it will gather the information from the knowledge base. So then the observation is done by reading the output, and then finally it will reflect on the result, and if result is not as expected, it will redo the cycle. So tool utilization and orchestration. So orchestration agent can use external search, that is API call. It can use vector database, retrieval augmented generation for if the internal knowledge is available, and validator. Yeah, so something like a company like Google having or a Bing having a search engine, and they have indexed all the worldwide data and information, which can be put into the vector database and retrieved. So additional information can be used to gather and provide the output, right? In such situations, instead of using LLMs which supports larger tokens or which have been trained on high number of parameters, instead of that, LLMs with smaller size can be used. So multi-agent collaboration. So how does advanced work to get the desired output? So like in my personal case, my daughter asked me like I'm in a 10th grade. After 2 years, I want to do aerospace engineering. So I created one agent as a student, another agent as an education consultant, and after 20 rounds of interaction between the two, I gave the output to the notebook LM and created a podcast which she listened to it. Similarly, there was another example where I had a property tax assessment and I wanted to protest it. So I created one agent as a owner, another agent as a property agent consultant, and that conversation I summarized it and I used it to do the protest, and it was accepted by the county evaluator. So how it can be done is for any solution you have a generator agent which generates the information, and you have the output, and that output is given to the critic agent. That critic agent will evaluate and provide its output, which can generator agent can look into it and respond. So like if the critic agent says it is too technical for a beginner, mention index funds, comparison, check bias, and so on, then generator agent will act on that input and further refine the output it created. Synthesis, convergence. So how we converge, right? So whenever any output comes, you can define the agent will score based on different criteria. So like in this case, what is the confidence on benefit data, what is the confidence on risk data, suitability analysis, and how to do confliction resolution and merge, and finally provide the unified response. So whatever it has been mentioned here is with the help of an example, but when we actually see the dynamic generation of such agents, we will see how this thing is dynamically created and executed in the next video. So output, as always, output generation and guardrails. Guardrails are to check the accuracy for the safety and check the tone of the output given, and before sending it to the user. And very same thing, if required, we can have a human review done, and if there is an error message, the error message can be recorded into the log. Yeah, so as I mentioned at the start, proactive engagement, the agent can provide the set of questions, which follow-up questions which user may ask. In such solutions, we need to maintain two kinds of memory: short-term memory and a long-term memory. So short-term memory is the conversation happening So whatever, if the conversation goes beyond 5 to 10 rounds of conversation between the solution and the user asking question, at certain steps summary, context summary can be done, which I will include in the future videos as part of intermediate and advanced learning. For long-term memory, the information can be stored into the vector database and can be retrieved need basis using retrieval augmented generation. Right, so the benefits of such dynamically generating domain agnostic solution is we don't need to re-engineer and program for every different question asked by the users. It helps increase the accuracy and address the larger audience. The solution is scalable and guardrails can be used for safety. So if you think certain components will be common, like guardrails for the input and the output cache to store the short-term memory, vector database for the long-term memory, orchestrator, reason and act, and so on. So certain components are common, so those can be defined and reused in such solutions. So so our solutions are ethically compliant and safe. So let's review the summary on what we use. So the framework was LangGraph. So if we use other technologies, we can use step functions, state machines. We need natural language understanding, so we can use traditional NLP along with large language models. I can have later some videos and sessions on NLP. Long ago, 25 years back, when generative AI was not existing, I had an opportunity to work on a project where a system user would have a dialogue with a system to arrange meetings and emails and so on, using Shank's theory of verb valency. Okay, so for execution pattern, we use reason and acting. For safety, we use guardrails, and for PIA, we can use Privacera, Ranger, or Protegrity kind of solutions. For the memory architecture, we use VectorDB for long term and Redis for short term. And for integration for APIs tools, we use REST APIs. So let's do the quiz before we close. I will also share the quiz on the blog. So what is the primary principle behind the agentic solution design for domain-agnostic question answering described in the text? You can pause the video, you can think about it, and choose the options provided. If you are not able to, revisit the video, or you can see the hint and do the scoring of your confidence on the subject. The next question is, in the context of natural language understanding, how does the system typically identify the domain of a user's question? Next question, what role do conditional ages play within the LangGraph workflow orchestration? How does React pattern facilitate real-time adoption in agents? We will do some sessions on different types of agents, human agent, React, and so on. What is the function of output guardrails in this agentic system? In the two-agent conversation loop approach, what is the specific purpose of the second agent? Thank you. I'll post the remaining questions on the blog.